Okay, so let's have a look at this. First thing, factor. So hopefully the factoring was okay. X times x squared minus 1. The bottom, don't worry about it. I don't know how to factor that either. So you can at least factor the top out though. Okay, zeros. Ethan, what are our zeros?
0 and plus or minus 1.
Okay, and then the y-intercepts. Andrea? Yes. Just by plugging in 0 for x. Okay, find the equation for each horizontal and vertical asymptote of this function. So how about horizontal asymptote? Mary, what'd you get for that? Yes, great. And then vertical asymptotes, Mary Elizabeth?
I got x equals, well, the fourth root, I guess.
Yeah.
Plus or minus. Wait, would it be plus or minus?
Yeah, let's see how we get that. So if you set the denominator, set this piece equal to 0, that's how you find vertical asymptotes. You get 2x to the fourth equals 1, or x to the fourth equals a half. And so you take the fourth root of both sides, but you realize that both the positive and the negative fourth root, if you put them to the fourth power, would give you positive 1/2. So x does equal plus or minus fourth root of a half. Not the prettiest looking number, but that's it. Those are your vertical asymptotes. And when we graph it, I'll talk to you about how to think about it. Describe the symmetry of the graph of f. So I said that, to find if it's even, then f of negative x has to equal f of x, or negative f of negative f of x. Sorry, negative f of negative x would equal f if it's odd. Yeah, Ian?
Wasn't the horizontal asymptote case 3? It wasn't one.
You're thinking about when the numerator is bigger than the denominator, and in that case, there's no horizontal asymptote. But when the denominator has a higher degree than the numerator, then there is a horizontal asymptote of 0. And if you think about it, it makes sense, right? The bottom grows much more quickly than the top does. So therefore, as you go out to infinity, you have a number divided by a much bigger number, and that goes to 0. Like, it starts off as 1 over 10, and then 2 over 100, and then 3 over 1,000. The numbers are going down, down, down to 0. So if the denominator has a bigger degree than the top, y equals 0 is a horizontal asymptote. So for the symmetry part, if our function f of x is x cubed minus x over 2x to the fourth minus 1, we try f of negative x, which would be negative x cubed minus negative x over 2 times negative x to the fourth minus 1. Those simplify out as follows: negative x cubed plus x over 2x to the fourth minus 1. That does not equal f of x, so it's not even. So in other words, what we're saying is the right side is not the same as the left side. F of x, the right side, is not the same as the left side, f of negative x, so not even. It's not symmetric about the y-axis. But negative f of negative x, that would be just putting a negative in front of all of this. You can either distribute it to the numerator or the denominator, not both, right? If you did it to both, that'd be like you're multiplying by negative 1 over negative 1, which is 1. But you're just multiplying by negative 1 over 1. So just put it to the numerator, and you see that you get x cubed minus x over 2x to the fourth minus 1. So therefore, f is odd, which means f is symmetric. Symmetric about the origin. That's how we say it. So in other words, it's reflected across the y-axis and the x-axis to be odd. And then to put up the graph, let's see. So I'll be kind of big here. We know we have vertical asymptotes somewhere at the fourth root of a half and the negative fourth root of a half. So that's somewhere in here. So I'll just say fourth root of a half somewhere in there and negative fourth root of a half. We know we have a point at the origin. We know we have x-intercepts at 1 and negative 1. We know it's odd, so if we can figure out the right side, then the left side will just be the double flip of it. So, oh, we know we have a horizontal asymptote at 0. So kind of a strange looking graph. So let's figure this out. If you plugged in something, let's see. So if I plugged in a number that was just slightly bigger than our first vertical asymptote, so something slightly bigger than the fourth root of a half. Okay? Something slightly bigger than the fourth root of a half. So f of something slightly bigger than that. Well, on top, it looks like, well, that would be a positive x. If it's just plugging that in for x, that would be positive. Times fourth root of a half plus 1 is positive. And then fourth root of a half minus 1, negative. Right? So we've got positive, positive, negative, and then on the bottom, something slightly bigger than the fourth root of a half would be minus 1. Positive or negative? Positive. Oh, which one is it? Positive. Because if you raise a fourth root of a half to the fourth, you get, oh, actually that one's kind of confusing. Wait, let's think about this for a second. Because the fourth root of a half is a strange number, right? You go slightly bigger than that. No. It should still be bigger than a half. Right. God bless. Yep, positive. So that's negative. So then over on this side, must be negative. If you want to see if it crosses the axis or it goes just bounces off the axis to go further to the right, you could just plug in 2 and see if it's positive or negative. So you can just plug in 2 for f. So that would be f of 2 would be 2 cubed minus 2 is 8 minus 2 is 6 over 2 times 2 to the fourth. That's 32 minus 1 is 31. So you can see it does go over it. And that means by odd symmetry over here, it's got to be the opposite kind of thing. Then in the middle, you would try going to 1/4 root of a half from the left, and you would see that it goes up to infinity, and the other side goes down to negative infinity. Yes, sir.
Okay, so it seems like whatever side the graph is going up, like towards the line, towards the the vertical asymptote, seems like the line next to it always goes the opposite way.
So that is true when the factor that corresponds with that vertical asymptote has an odd multiplicity. So like let's say in the denominator, so in this case, we didn't get to factor the denominator. The bell's about to ring. If it was just x minus 1 and the vertical asymptote was at 1, then it would go up 1, down the other, or vice versa.
Just a reminder, for H block, Coach Anderson, Miss Joan Williams, and Coach Matthews' classes are meeting in the gym. Also, a reminder, all seniors, you need to go directly to the gym when the bell rings.